Ever wondered why the speed of light is what it is and how it affects our understanding of the universe? Let's delve into the fascinating world of space-time. Picture space-time as a cosmic fabric that is warped and bent by the mass and energy within it. This is the playground of light, which zips around at a staggering speed of approximately 186,000 miles per second. But why this speed and not any other? Well, the speed of light isn't just a number thrown into the mix. It's a fundamental constant of the universe. It emerges from the very structure of space-time itself. It's the cosmic speed limit, if you will. Nothing can travel faster than light, and this speed limit is deeply woven into the fabric of space-time. So, the speed of light is much more than a measure of fast. It's a cornerstone of our understanding of space-time. But what is space-time really? This question has puzzled scientists and philosophers for centuries, but today, we're here to unravel this enigma. Space-time, as it is commonly understood, is the four-dimensional fabric of the universe. Now, imagine a quilt, stretched out in all directions. This quilt represents the universe, and each patch of the quilt signifies a specific point in space-time. But here's where things get interesting. This quilt isn't flat. It's a four-dimensional fabric with three dimensions of space, length, width, and height, all stitched together with the fourth dimension, time. Just as a thread weaves through a quilt, time weaves through the fabric of space-time, binding the three dimensions of space together. The interplay between these dimensions is what gives us our perception of reality. We move through space over time, constantly shifting our position within this four-dimensional fabric. And just like how a needle leaves a trail as it moves through a quilt, we too leave a trail as we move through space-time. Now let's add another layer to our quilt analogy. Suppose you place a heavy object on the quilt. What happens? The object causes a distortion, a dip in the fabric. The heavier the object, the deeper the distortion. This is similar to how objects with mass distort space-time. The distortions caused by mass are what we perceive as gravity. It's not that objects are being pulled towards each other by some unseen force. Rather, they're simply following the curves created by these distortions in space-time. This is why Earth orbits the Sun, why the Moon orbits the Earth, and why an apple falls from a tree. So when you're standing on Earth's surface, you're not just standing on a planet, you're standing on a massive distortion in the fabric of space-time, and the force you feel pulling you down is simply space-time guiding you along its curves. So, space-time is the stage on which the cosmic drama unfolds, and everything that happens is governed by its rules. And where does the speed of light fit into all this, you may wonder? Well, the speed of light plays a central role in our understanding of space-time. It's an intriguing fact that the speed of light remains constant for all observers, regardless of their speed or direction. Imagine you're in a spaceship, traveling at half the speed of light, and you decide to switch on your headlights. The light from your headlights will still travel at the speed of light, not half as you might expect. This constancy of light speed leads to some mind-bending phenomena, such as time dilation and length contraction. Time dilation means that time moves slower for an object in motion compared to an object at rest. On the other hand, length contraction suggests that an object in motion will appear shorter in the direction of motion to a stationary observer. These are key predictions of Einstein's theory of relativity. Thus, the speed of light is not just a speed limit, it's a fundamental property of space-time itself. So, what have we learned about the speed of light and space-time? We've unraveled the enigma of space-time, a four-dimensional fabric that warps and bends under the influence of mass and energy. We've understood that space-time isn't just an abstract concept, but a tangible reality that governs the motion of celestial bodies and even the path of light. Speaking of light, we've discovered that it travels at an astonishing speed, approximately 186,000 miles per second. This speed is a cosmic speed limit, a constant that remains unbroken, irrespective of the observer's motion relative to the light source. We've also delved into the fascinating implications of these principles. The interplay between space-time and light speed shapes our understanding of the universe, from the expansion of galaxies to the ticking of time itself. Remember, the next time you look up at the stars, you're not just seeing distant lights, you're glimpsing the very fabric of space-time itself.